The word equation for the reaction between hydrogen sulfide, H2S and oxygen is shown. The mass of the oxygen is required to react with 5.1 grams of hydrogen sulfide. Okay. This is a huge process. This way is enough to do it here. I'll build a separate page in it. So first we need to find the molar mass of hydrogen sulfide, because here the stoichiometric coefficients are given. So you can compare the moles amount. Got it? But you can't just compare the moles amount. You need to have the amount of moles of these substances. Here, the mass is given. If you divide it by the molar mass of hydrogen sulfide, we can get the moles of hydrogen sulfide. That's why we are finding the molar mass of hydrogen sulfide. And this is a common knowledge. Hydrogen, the molar mass is 1. Sulfur, it's 32. The unit is grams per mole. I hope you guys know this, huh? Okay. So, 2 hydrogens plus 32. It's 34 grams per mole. We don't have to write in every single one as this is an MCQ. 5.1 grams divided by 34 grams per mole. You will get the number of moles. Number of moles is equals to 0.15 volt. Okay. Is this the answer? No. We want the mass of oxygen. So you can do something like this. Moles of H2S to the ratio of moles of O2 is 2:3. Okay. Similarly, we know the moles of hydrogen sulfide now, which is 0.15 mole. But we don't know the moles of O2 needed. So we can subtract this. When we subtract that, we get 0.15 multiplied by 3 divided by 2. If you do this, this is 1, this is 1.5. So 0.15 multiplied 1.5. So it is 0.225 moles. The question is still not over. You know the equation, moles equals to mass over molar mass. We need mass. That means moles can be multiplied by the molar mass. Mole is, number of moles is 0.225. Molar mass of O2 is 16 times, because for 1, 16, there are 2, so we multiply by 2. So if you do this, you will get 7.2 grams. So the answer is C. Which apparatus is used to plate nickel object with silver? Nickel object with silver. Okay. You have a nickel object. You are coating it with Ag. So Ag is the one who is going to deposit on nickel. So Ag should undergo a reaction like this. Okay. So the solution should contain, as Ag wants to undergo a reaction like this, the solution should contain Ag2 plus in the electrolyte. So you can eliminate by considering that. C and D obviously wrong, because the electrolytes are nickel nitrate and nickel nitrate. Obviously the answer should be A and B, A or B. And here Ag is Ag2 plus. So plus means it lights negative side. So nickel should be kept in the negative terminal. So answer is A. The Ag will deposit here. Ag2 plus will deposit here, gain electron and form a in this nickel object. Next one. When an acid is added to an alkali, the temperature of the reaction rises. Describe which words describes this reaction. The temperature rises. Temperature rises means obviously exothermic reaction. And added. It's a neutralization. And remember, all the neutralization reactions are All neutralization reactions are exothermic. That's for sure. Some properties of four fuels are given. Each fuel is gas at room temperature and makes two products when it burns in plentiful supply of air. Okay. So octane. Octane is not a liquid. Okay, it's like octane is given in the it's considered in the normal proposal. And wax is solid. This is liquid. This is solid. Yeah. The boiling point is 126, so obviously it can exist as liquid. Okay, hydrogen. When you burn hydrogen is gas. This is a gas. Yes. And methane is also gas. So the answer is A or B. When hydrogen is burned in presence of oxygen, it produces H2O as the only product. This is the reaction that happens in hydrogen fuel cells. Okay, and but the next one, which is methane, CH4, yes. When it is burned with oxygen, I'm not going to write the balanced equation. I just write. It produces carbon dioxide plus water. Okay, so it produces. They say it should produce two products. So the answer is A. Next one, dinitrogen tetroxide or N2O4 is converted into nitrogen dioxide NO2 in a reversible reaction. Okay, the forward reaction is endothermic. And the reverse reaction is exothermic. Okay, the sign of endothermic is plus doubt to be confused. Okay, so let's say if the forward reaction is endothermic, when we increase the temperature, what happens to the favorability of the reaction to forward direction? It increases. Okay, the equilibrium always tries to work against the change. So when you increase the temperature, it will become endothermic. It will absorb as most temperature and come back to the original temperature. It will always oppose a change. Similarly, when you increase the pressure, it will try to reduce the number of molecules in its state. Okay, so we need to convert in which conditions give the highest equilibrium yield of nitrogen dioxide. That means we need to get more nitrogen dioxide as possible. So what should we do? We have to decrease the pressure as much as possible because here two molecules are there. So we have to decrease the pressure as much as possible and increase the temperature as much as possible. So the answer is A. Okay. Dilute hydrochloric acid is reacted with excess calcium carbonate and the total volume of gas is measured at regular intervals. The results are shown by the line W on the graph. This graph, the experiment is repeated but with one change. The results of the second experiment are shown by line X on the graph. Okay, which change is made in the second experiment. Okay. So they're talking about rate of the reaction. What are the factors that affects the rate of reaction? Temperature, concentration or pressure, catalyst, surface area. So when temperature increases, reaction rate increases. When concentration or pressure increases, rate increases. Catalyst is present, increases. Surface area increases, obviously the rate increases. Okay. So when the catalyst is added here, they are asking what is the change that could have happened in X. Here you can see the reaction has obtained the final point much quicker. The time is much less. But when it comes to X, it has taken a lot of time. Okay. Yeah. So you can say the rate of reaction has decreased in the second. When a catalyst is added, rate of reaction increases. So first one is false. Calcium carbonate is broken into small pieces. Surface area increased. So this first one is wrong. This one is also wrong. If you do this, rate of reaction will increase. Concentration of dilute hydrofluoric is increased. Now, if you increase the concentration also, it increases. Temperature of the is decreased. Yeah, when we decrease the temperature, reaction rate decreases. When hydrated copper 2 sulfate is heated, it produces white copper sulfate. When water is added, the white copper sulfate turns to blue. Okay, so it's easy, right? If initially it is blue, you heat it becomes white. When you add water again, it becomes a reversible reaction. We cannot say decomposition because nothing has broken. We cannot say displacement as all of the elements has displaced. There's no oxidation or reduction happening. It is also not possible. When magnesium is treated with zinc oxide, a reaction occurs. The equation is shown. Okay. Which substance is oxidized? What do you mean by oxidized? Oxidized means the oxidation number increases. Oxidation number increases. Okay. So magnesium, you have to compare, it's 0. Zinc plus 2. Oxygen minus 2. Magnesium, here it becomes plus 2. Oxygen minus 2. Zinc is 0. Zinc has gone from plus 2 to 0. It has reduced. I'll use a different color pen now. Magnesium has gone from 0 to has gone from 0 to plus 2. So it has oxidized. Substance is oxidized, magnesium. That we'll leave the 17th question as it's a huge temptation. Under it at the end. Let's go to 18. Ethanoic acid reacts with water to produce an acidic solution. Which row describes the role of ethanoic acid and water in this reaction? Okay. Ethanoic acid accepts proton. What is the purpose of an acid in water? It liberates H+. So it donates a proton. And water accepts a proton. Water will accept this one and liberate H2 and OH. Tests are done in aqueous solution. Test a few drops of aqueous sodium hydroxide are added. Right present to this form. Aqueous hydroxide is excess in solution. This is direct theory. It's 1 and 3. There's no reaction calcium like that. So is B. Ammonia, NH3, dissolves in water to form dilute solution of ammonium hydroxide, NH4OH. The reaction is reversible and exists as an equilibrium reaction. Okay? Which statement about the mixture is correct? All of the ammonia and water molecules are turned into ions. No. What is the specialty of an equilibrium reaction? Both reactants and the products will remain in the reaction at all, always, if it are certain and equilibrium. The ammonia and water molecules have stopped changing twice. This is also obviously wrong. They always keep changing, always moving from front and back. The concentration of the ammonia molecules and ammonium ions are always equal. That one, that might seem correct, but let's go to the next one. The rate of the formation of ammonia molecules is equal to the rate of formation of ammonium ions. This is the definition of equilibrium. So the answer is D. Therefore C is